Hi everyone, welcome back to my YouTube channel. So today we are going to solve day 14 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2762, continuous subarrays. So let's read the problem statement first. You are given a zero indexed integer array nums. A subarray of nums is called continuous if let I plus 1, j be the indices in the subarray. Then for each pair of indices in that particular subarray, okay, the difference between two numbers should be less than equal to 2. Okay, in that case only our subarray of nums is called continuous. We have to return the total number of continuous subarrays. A subarray is a continuous non-empty sequence of elements within an array. Okay, so now let's understand this with example number 1. All right, so here continuous subarray of size 1. Okay, so this is a continuous subarray of size 1. Okay, so total 4 are there, right? 5 4 2 4. Okay, and then continuous subarray of size 2. Here see 5 and 4. So max element in this subarray is 5 and min element in this subarray is 4. So difference is 1. Okay, we are good. Difference should be less than equal to 2. Okay, here this, see this 4 and 2, difference 2. Okay, so this condition is satisfied here. Difference between max and min element is satisfied, right? Less than equal to 2. Okay, now see the continuous subarray of size 3. So here in this case total 3 are there, right? Subarrays. So now continuous subarray of size 3. So 4 2 4 4 2 4. Why? Here see difference between all the pairs, okay, is less than equal to 2. Okay, so you can directly check actually using this now. Min element is 2, right, and max element is 4, right? So difference between max and min itself is less than equal to 2, then definitely the difference between other pairs is always going to be the less than or equal to 2 as well, right? If the difference between max and min is less than equal to 2, that's it, right? So now we are not selecting this pair 5 4 2. What is the reason behind this 5 4 2? We haven't selected this. So in this case, if I just pick this pair 5 and 2, okay, I see this pair. So here max element is 5, min element is 2, difference is 3. Okay, so this is greater than 2. Okay, greater than 2. That is why this is not a continuous subarray. Okay, a subarray norms is called continuous if the difference between them is less than equal to 2, right? So that is why we are not picking this subarray. Max element is 5 and min element is 2. Okay, difference between them is greater than 2, right? So that is why we are not picking, and definitely we are not going to pick this as well. Okay, complete, because max is a 5 and smaller is 2. 5 minus 2, difference is greater than 2. So that is why it's not a continuous sub array, right? So we are not picking this. Okay, so in the end we have these 4 plus 3 7, 7 plus 1 8 8 8 is my output, right? So I hope that you guys are clear with the problem statement. Okay, so now how we are going to solve this problem. Okay, so let's see. 5 4 2 4. Okay, so let's pick this example only. 5 4 2 4. Okay, so we are going to use sliding window approach here. Okay, so one thing that we know here, that the max element in our window, okay, max element in our window and minimum element in our window, okay, the difference between them should be less than equal to 2. Okay, so this is what we know. Okay, for our window to be valid, right? So here do one thing. Here take my left pointer starting from here, right, and my right pointer starting from here. Okay, so now uh, there is just one element. Okay, so see this right pointer is at this position only. Okay, so left is fixed right now here at my index number 0. Okay, so 0 index, 1 index, 2 index, and 3 index. Okay, left is fixed here. All right, so now this is just a single element. Okay, so just create one variable, let's say count. Okay, and in count I'm just going to count the number of valid continuous subarrays. Okay, so just 5, just 5. Okay, so here just 5, so it is a valid now. So here increment the count to 1. Okay, increment the count to 1. Okay, now move my right to the next pointer. Okay, so my right is going to move to this position. All right, so see this is also valid now. 5 and 4, if you see, this is also valid. The max element here is this 5 and min element is 4. Okay, and let's say I'm creating one map as well. Okay, sorted map. Okay, so here 5 frequencies one based on their keys, it is sorted. Okay, so 5 frequencies one, I have added this 5 here. Okay, 4 frequency uh, 4 frequencies 1. Okay, so I have added this. Okay, 4 frequency I have added this. Okay, so now this is valid, right? This is again valid, 5 and 4. Okay, so this is also valid. So here my count, let's say I change it to 2. Okay, here one second, not just change to 2. Here I have to show you few more things. Okay, so I am saying that this window is valid. Okay, this window is valid. Okay, 5 and 4, this window is valid. Okay, this is what we know here, because the difference between the max and min, okay, is less than equal to 2. Okay, so now here previously it was 1 when just 5 was there, but here I have to add 2. Why? Because 5 and 4 is valid, also 4 is also valid, na? 4 is also valid subarray, right? So here in this one I am adding 2, right? 1 plus 2, I am adding 2, right? Okay, so now here how I'm going to calculate this 2. Okay, I know this 2 visually here, that 5 4 is 1. Okay, and 4 is 1, but how come I'm going to write this in code? Okay, that this 2 is so simple. So here this is a valid subarray. Okay, so here I will just apply this formula: right minus left plus 1. Okay, so right index is 1, left index is 0, plus 1. So what is output I'm getting? I'm getting output as 2. That simply means that there are two valid subarrays which are starting from this left and ending at this right or right. Okay, so now let's say my R is moved to next position. Okay, so now there is going to come one issue here. Okay, so now see this. Okay, so now here 2, so let's add this 2 frequency. Here I have added 1. Okay, 2 is 1, but now if you see the difference between topmost and this one. Okay, so here this is this element. Okay, the first entry and the last entry. Okay, so if you see the difference between them, so you will see that difference is greater than 2, right? 5 minus 2. Okay, the difference is greater than 2, right? So this is not a valid window. Okay, this is not a valid window, right? So in this case what I'm going to do, I'm going to increment my left pointer to the next position. So my left pointer is going to move to this position. All right, so now I have to check this window. Okay, and now if I am checking this window, then we have to remove the frequency of this one, right, from our tree map. Okay, so here I am just going to remove the frequency of this one. Okay, I have removed this. All right, and now this is valid. Okay, this is valid. So here in this window, what are the two valid subarrays that you are seeing? You are seeing 4 and 2, 4 and 2. Okay, this is one valid and this is one valid too. Okay, so only two are there in this window, and with the formula can we get that r is 2 minus 1 plus 1, so we are going to get 2 only. Okay, we can apply this formula. So here I am adding 2. All right, okay, I have added 2. Now my r is going to move forward. Okay, my r is going to move forward. All right, so now my r reaches here. Okay, so now I am going to check this window. So this is valid now. So here max element is 4 and min element is 2, so difference is greater than equal to 2. Okay, difference is less than equal to 2, so in that simply means that it is valid. Okay, so here what are different pairs that you are seeing here? 4 2 4 is the one that you are seeing. Okay, 4 2 4, then 2 4 is the one that you are seeing. Okay, 2 4 is the one that you are seeing, then 4 is the one that you are seeing. Okay, so total 3. So can we get this using formula 3 minus 1 plus 1? So yes, we are going to get that. So here I'm adding 3. Okay, so this is done. Now my r is going to move out of bound. Okay, so here update the frequency of 4 to 2 as well, right? So r moves out of the bound. Okay, so here what is the total count? 3 5 6 7 8. 8 is the output, right? So here see we are getting this 5 5 5 4 and 4. Okay, so 5 5 4 and 4. All right, and then we are getting 4 2 and 2. Okay, 4 2 and 2. Okay, then we are getting 4 2 4 2 4 and 4. Okay, 4 2 4 2 4 and 4. Okay, so we have covered all the elements, right? So this is clear, and we are using this tree map just to find the difference between the max element and the min element in that particular subarray. Okay, that is the only use of this one. Okay, so that is why we are maintaining this. Okay, so I hope that you guys are clear with the explanation. Now let's write the code for this one. Code is going to be very simple for this problem. Okay, so here, so let's move to the coding part now. So here let's create one tree map, and tree map is consisting of keys, okay, as my numbers, and values as frequency. Okay, so integer only. Here give frequency is equal to new tree map. All right, and take one variable count is equal to 0, and take left equals to 0, right equal to 0. Okay, and take n as nums dot length, and here while right is less than n, here just add the element in my map. Okay, frequency dot put nums of right. Okay, so whatever there at my right index, I am adding that in my map. Okay, so this is what I was doing, right? So frequency dot put nums of right. Okay, and here just check if we have this key in the past or not. Okay, so get or default. Okay, so get the value from this key. Okay, if it is already there in the past. Okay, if it is not there in the past, then let's get started from 0. Okay, and add 1 to it. Okay, this is done. Then after that, this is going to be a little new thing. Okay, for most of you guys. Okay, this line, while, now see carefully, while frequency dot last entry. Okay, last entry. Okay, whatever the last entry that we have, dot get key. Okay, last entry dot get key minus. Okay, so whatever the last entry that we have, so max 1. Okay, from max 1 we are going to subtract minus 1. Okay, so here minus frequency dot first entry. Okay, dot get key. Okay, this is a little new things, right? Most of you guys heard for very first time, right? This last entry and first entry function, right? Okay, so if the difference between them is greater than 2, that simply means that that window is not valid. Okay, so if that window is not valid, so what we are doing, we have to remove this leftmost part. Okay, so here I have to write frequency dot put, okay, nums of left. Okay, this key. So here for this key, get the value frequency dot get nums of left. Okay, and here subtract 1 from it. Okay, and after that, here just write if frequency dot get nums of left. Okay, if it is equal to 0, all right, then we have to just remove that particular key. Okay, so here frequency dot remove. Okay, nums of left. So all these operations actually are going to take logarithmic k time complexity. Okay, inserting the element, removing the element, and checking the first entry, last entry. Okay, getting the key. So all these are taking logarithmic k value. Okay, and you know, that we are only maintaining this difference. Okay, in this tree map the difference is always going to be less than equal to 2. Okay, so like 0, 1 and 2 we can put as keys. Okay, so difference is not greater than 2. Okay, if it is greater than 2 then that is not becoming a valid window, right? So we are removing side by side. Okay, so I can say that this is a little bit constant only. Okay, the size is constant only. I am not going to make it a larger, right, size, because difference is always going to be less than equal to 2. Okay, only those keys are I'm inserting. Okay, so if any other keys coming out, coming inside, then I'm removing the first one. Okay, the leftmost one, right? Okay, so this is done, and here we have to update my count as count plus right minus left plus 1. Okay, and here increment the right. Okay, and in the end we have to just return the count. Okay, that's it. All right, so here let's run it. Okay, so we are doing the sorting on very few elements, right? So of n log n, or n of n, you can say time complexity. Okay, so let's submit it and let's see. So we are just iterating over all the elements, right, using this while loop, right? So here if you see the time complexity, so here you will see of log n. Okay, so you can actually remove this. Okay, no need to write. Okay, because size is fixed, right? So that's why, that's the only reason I'm saying that. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.